Hello everyone. In this video, let us see how to determine if the given LTI system is causal or non-causal. So we already had started in the first chapter to determine if a signal is a causal signal or a non-causal signal, right? But here it comes about the LTI system, that you have to check if the particular LTI system is causal or not. So you know that LTI system, it will be always characterized, okay, or its properties can be determined by using its h of t, that is nothing but the impulse response h of t, right? So whenever they mention about this LTI system, they will be giving you this h of t signal, okay, that is impulse response signal will be given to you. So based on that, you have to check if the system is causal or not. So we know that for a signal, for a particular signal x of t, if they give you some signal x of t, how are you telling whether that signal was causal or not? So if that signal, if it was depending on the particular, means if y of t is something like it is equal to x of 2t, okay, it was a signal which was given to you. So now you were telling if this y of t was causal or not depending upon the values of t. That means if the output, if this y of t, if it depends upon the present and the past, present or past, or you can only consider past, or you can only consider present. Okay, so if it was depending upon these three values of the input, then this y of t, it was a causal signal. Suppose if it was depending upon the future values, okay, suppose like t is equal to 2, you will be having y of 2 is equal to x into x of 4. So that means it is depending upon the future value of the input. In this case, the y of t was actually non-causal signal. Okay, so this was when it comes to the signal. So likewise, for the LTI system, we will be seeing this impulse response signal h of t. So if h of t is a causal signal, if it is a causal signal, then LTI system is causal. LTI system is causal. Okay, so h of t should be your causal signal. That is, h of t is equal to 0 for t less than 0. This is the condition that has to be satisfied. Okay, this is a condition that has to be satisfied for the LTI system to be causal. Suppose if there is any some finite value, okay, h of t is not equal to 0 for t less than 0, then this is a non-causal system. Okay, when it comes to signals, we saw that if there is any signal something like this, okay, this was the delayed version, right? If it is in the right, means suppose you have x of t like this, then after delaying I got something like this. So this is my causal signal. What about this? This is a non-causal signal, because here we can see it is present on the right side also, it's present on the left side also. Suppose you have the signal completely like this only on the left side, then this is called as the anti-causal signal. Anti-causal signal. So if your h of t is something like this, okay, or something like this, okay, then this is the causal signal. If h of t is something like this, it is the anti-causal, or if it is depending upon both, then it is called as non-causal signal. So based on h of t, we can tell whether the system, LTI system, is causal or not. Okay, so from the formula also you can determine, see, y of t is equal to minus infinity to infinity x of tau h of t minus tau, then you have t tau, right? See, this is the input, right? X of t is the input, y of t is the output. If this output, if it depends upon the past and the present values, past and present, or only past or only present values, then we can say that the system is causal. So for if you get y of 2, then you have x of 2, okay, and h of something, okay. So this you can see 2 and this is 2. That means it is depending upon the present value. So this is the causal system. Suppose you have y of 4 and here it is x of 2, okay, and h of something like this. So in this case, this is t is greater than tau. In this case, t is equal to tau. Okay, in this t is greater than tau. That means it is depending upon the past value of the input, because it is 4, this is 2. So this is also causal. Okay, but if you have y of 2, then here you have x of 4. This means it is depending upon the future value of the input. This will be your non-causal. Okay, so suppose if you are t, if it is greater than or equal to tau, then you can get the causal system. If t is less than tau, then you are going to get the non-causal signal, non-causal system. Okay, so you can also make this equal to 0 for this case. Okay, if to make the system causal, you can make h of t minus tau equal to 0, and that will happen when t is less than tau, right? When t is less than tau, you have to make this equal to 0. That time you can make the system causal. Okay, so this is to determine the if the LTI system is a causal or not. That is using the formula, using the convolution integral formula. Okay, so these are the different cases. So basically you have to remember h of t is equal to 0 for t less than 0. This is a causal system. Okay, so for example, I will give you h of t is equal to 3 delta of t. You know delta of t, it is equal to 1 when t equal to 0. So h of 0 is equal to 3 delta of 0, which is equal to 3. H of 1 is equal to 0, h of minus 1 is equal to 0, everything else is equal to 0. So it is depending upon this value. So we can consider that LTI system is causal system. Okay, so this is how we are going to check for the causality. But suppose if it was depending upon the other values, so for example, I can consider
like h of t is equal to 3 u of t plus 2. So here you have h of 0 that is equal to 3 u of 2, which is equal to 3, because you know unit step function that is equal to 1, that is for t greater than or equal to 0, right? So if I consider h of minus 1, in this case you will be having 3 u of minus 1 plus 2, that is 3 u of 1, again it is equal to 3. So now we can see that for t less than 0, h of t is not equal to 0 in this particular case. So this LTI system, it will be non-causal. So this is how we are going to determine if the particular LTI system which is given is causal or